Now, arc length and a sector area are pretty straightforward. Hopefully you already have heard of them in previous maths. So arc length basically just means part of a circle. So it could be the whole circumference, or it could be a part of a circumference. It could be this length, it could be this length, whatever you decide, they're called arc length. Okay. Sector area basically means this area, kind of like a pie. Whatever that arc decides to be, that area of a part of the circle, portion of a circle. And now hopefully you can see, because these are kind of segregated by angles, it can be a portion of the circle in terms of the degrees or radians in our case that we're learning now. Other words such as center, chord, radius are some things you should already know, and segment. Something to note, minor, whether that we're talking about arc, sector, or segment, it just means that it's involved less than half of the circle. Major just means that it involves more than half a circle. So as you can see, these are both segments. This one's a minor segment because it involves less than half the circle. This is a major segment because it involves more than half of the circle. Similarly with this arc length, it's a minor arc because it's less than half of the circle. This one's a major arc because it involves more than half of the circle. So using that sort of basic knowledge, with degrees, we know how to calculate it. Hopefully you've seen it. It's just basically 2 pi r circumference, and this just demonstrates what amount of the angle, this whole angle is 360, what proportion of that 360 degrees is this arc length. So all it is saying it's a proportion. It's a portion, I should say. So in order to change that into arc length, all you have to change is the degree. So I write my angle, and then instead of writing 360, I can just write 2 pi, because we know that 2 pi is the same as 360 degrees but in radians. And if I write this down, I should be able to kind of cancel out some things. You see how there's a 2 and the 2 there, one's times, one's divided, so it cancels out. There's a pi and a pi here, so it cancels out. It simplifies down to, so I should write length for arc length. So your formula just simplifies down to the angle times the radius. So as you can see, that's how we got that little formula, and that's just a little demonstration. Similarly, so that's all you have to use. This is the main formula you have to use. Similarly for sectors, you know that it's a proportion of the area of a circle. So that's area of the circle. And then this is just a part of it. Okay, if I want to change that to radians, all I have to do is change the 360 degrees to 2 pi again. Alright, let's see if I can simplify this any further. I can cancel out the pi's, so I get, so I should write area for A for area. So I get A equals theta r squared divided by 2, which is exactly the same as how they got that area. So I'm just demonstrating you how they got simplified down and got that area of sector. This is the most important thing you can use, and we'll give it a go. A sector has radius 12 centimeters. So let me write that little fact down. Angle 3 radians. Find its arc length. Okay, a sector, so I'm going to be using this one. So length is pi theta times r. So all I have to do is 12 times r, so I get 36 centimeters. And then area. The formula was half theta r squared, so all I have to do is go half times 3 times 12 squared. I'll just use a calculator for that. Which is 216 and centimeters squared, because it's an area. Alright, you should be able to do all of these now. Make sure you go and do these. Make sure you write the examples down, and then we'll come back for example 5.